In this lesson, we're going to look at something called the law of sines. Let's start with the warm-up. A ladder leans against a wall at an angle of 50 degrees from the ground. The ladder is 8 feet long. How high up the wall does it reach? So let's start by drawing a picture of the situation. So we're going to start with our triangle here. And we know that the ladder is 8 feet long. And it leans against a wall at an angle of 50 degrees from the ground. We want to know how high up the wall it reaches, so I'll call this x. Change colors here. All right, we can't use Pythagorean theorem because we only know one side, and it's a right triangle, so we can use SOHCAHTOA, or right triangle trig. So take a look at your 50. How are the two sides related to the 50? Well, we have the opposite side. We have the hypotenuse. So if you remember SOHCAHTOA, that's going to be sine. Sine of 50 degrees equals the opposite side over the hypotenuse. And if you're solving for a side, you can cross multiply. So put this over 1. Cross multiply, we'll get x equals 8 sine of 50. And you can type that in your calculator. Remember to be in degree mode. And it's about, maybe lines here, 6.12 feet up the wall. So by now you should know how to solve something that looks like this, where you have an angle, it's a right triangle, and you have one side and you're trying to solve for another side. But how do you solve something that looks like this? What's the difference between the two triangles? Well, this is a right triangle. This right here, to figure out if it's a right triangle, you can subtract from 180 because you should know there's 180 degrees in a triangle. So to find this angle, we would have 180 minus 59 minus 43. You'd want to check, is that a right triangle? Because if it is, then we can use SOHCAHTOA. And when you solve that, 78 degrees. So it's not a right triangle, it's called an oblique triangle. And if it's an oblique triangle, we can't use sine, cosine, or tangent to solve. So we're going to do a little investigation. And we're going to take a look at how we can use what we know about right triangles to solve something that is not a right triangle. So it says, consider the oblique triangle ABC shown to the right. Sketch an altitude from vertex B. So an altitude meets your... let's change colors here. An altitude meets the opposite side of the angle at a 90-degree angle. So altitude means height. So there's my altitude. Label the altitude K. All right, so there it is, K. The altitude creates two triangles inside triangle ABC. Notice that angle A is in one of the triangles and angle C is in the other. Using right triangle trig, SOHCAHTOA, write two equations, one involving sine of A and one involving sine of C. So let's take a look at this right here. Sine is opposite, which is K, over hypotenuse. In this case, the hypotenuse is C. So this is K over C. Sine, so here's sine. We'll do that in different color. Here's sine. The opposite side is K over the adjacent side, the hypotenuse, which is A. Okay, so we did use trig to set up the ratios. Sine is opposite over hypotenuse. Notice that each of the equations in question 3 involves K. Why does this happen? Well, K is the opposite side of each. Solve each equation for K. Okay, so I'm going to rewrite the equation to solve for K. So the first equation was sine of A equals K over C. Let's solve that for K. Get rid of the divided by C. How do you do that? You multiply each side by C. And this cancels. So we have K equals C sine of A. Let's do the other equation. The other equation was sine of C equals K over A. And again, how do you get K by itself? Multiply each side by A. This cancels. And we get K equals A sine of C. Okay, so we solved each equation. Next question says, since both equations in question 4 are equal to K, they can be set equal to each other. So they both equal K. So again, if K equals this and K equals this, then these two must be equal to each other because they're both equal to K. So let's rewrite that. I'll change the thickness of my pen here. So let's set them equal. C sine of A equals A sine of C. Set each equation. Okay, notice that the equation question 5 no longer involves k because we set them equal. Write an equation equivalent to the equation in question 5, regrouping a reassign a, c reassign c. So we want c is on one side, a is on the other. So let's divide this side by c. We get sine of a equals a sine of c over c. Let's get rid of this a by dividing each side by a, and that cancels. So we have sine of a over a equals sine of b. Oh, sine of c, sorry. Sine of c over c. Okay, this is actually part of the law of sines, and we're going to use that to solve for oblique or non-right triangles. But we have one more thing to look at. So again, consider this triangle. This time sketch an altitude from vertex C, again altitude, meets the opposite side at a 90-degree angle. So here we go. There's our altitude here. And label that side K. All right, here we go, K. And again, let's do what we did before, except we're going to look at sine of A and sine of B. So sine of A, here's A. Sine is opposite over hypotenuse, so it's going to be K over B. Ooh. And let's look at sine of B. So here's B, it got cut off. And again, the sine is opposite K over hypotenuse, which is across from the 90A, K over A. Again, notice that each of these equations have K in them. Let's solve each of these equations for K. So like we did before, we got rid of the divided by B and the divided by A. So let's rewrite these equations. And they were sine of sine of A equals K over B. To get rid of the divided by B, we multiply each side by B. So K equals B sine of A. And the other one we had sine of B equals K over A. And to get rid of the A, we can multiply each side by A. So times A times A. All right, so here it is. B sine of A equals K and A sine of B equals K. Since both equations in equation 10 are equal to K, set them equal to each other. B sine of A equals A sine of B. And we can get B on one side by dividing this by B. These cancel. Let's get A on one side by dividing each side by A. So these cancel. And we have this. Sine of A over A equals sine of B over B. And remember, sine of A over A also equaled sine of C over C. This is called the law of sines. This is what we're going to use to solve for non-right triangles. So let's go ahead and do a few examples of how you use this law of sines. First of all, we'll write it one more time. So for any oblique triangle A, B, C, remember the sides across from the angle are the lowercase, so there's side B, here's side A, here's side C. The law of sines is this. The sine of A, the angle, over the side A, that ratio, equals the sine of B over B, so it's angle over side, and that equals sine of C over C. When you're using law of sines, you choose any two to use. You don't use all three at once, just any, you use one of the proportions. Let's try this one. Find all unknown angle measures and side lengths. Again, you would take a look, is this a 90-degree angle? And if we take 180 minus 110 minus 30, that leaves us just 40 degrees. So no, we can't use right triangle trig. Let's find all unknown angle measures and side lengths. So you can choose what you want to solve for first. Let's start with our complete ratio here. So this is the ratio that we have both the side and the angle. So we have to start there. It's going to be sine of 30 over the opposite side 5. Okay, pick one of the other ones to solve for. So I'm just going to solve for A right here. You can choose, do both of them. So we'll solve for this one. So this equals sine of 40 over A. We're going to cross multiply and solve. So when we cross multiply, we'll get 5 sine of 40, go this way, equals A sine of 30. The sine of 30 is a number, so to get A by itself, divide each side by sine of 30. Oops. Let's try that again. And in your calculator, remember to be in degree mode, type this in. 5 sine of 40 divided by sine of 30. And we will get the length of side A. So I did this ahead of time. I got A is about 6.4 centimeters. Okay, so now we have to solve for side B. So let's put a B here. Sine of 110 over B equals, and you can use either one of the ratios, but since we rounded for A, I'm going to use the first ratio that we had because the number is exact. So we have sine of 30 over 5. Again, you cross multiply and solve, so we'll have B sine of 30 equals 5, so we went this way, equals 5 sine of 110. Divide each side by sine of 30. My Mobi would work here. So divide each side by sine 30. This cancels, and I did this ahead of time. I got B is about 9.4 centimeters. Okay, so there's law of sines. It's just setting up a proportion and solving. Okay, we have 2 examples here. Find the unknown angle measures and side lengths. Okay, so again, start with your complete ratio here. And so if you notice, that would be this right here. Sine of 105 over 12 equals sine of, and the side I know is 4, and that goes with f. So I have to use that. Sine of f over 4. Okay, cross multiply. 4 sine 105 equals 12 sine of f. Get rid of the 12 first, so divide each side by 12. So sine of f equals, let's pop up my calculator here. All right, so you type that in and leave that answer in your calculator so we're not rounding, but if I round, so it's about 0.32, but again, leave that in your calculator because now to get rid of the sine, you take the sine inverse, and in your calculator, to get the most exact answer, you should do sine inverse of your last answer. So you can type in 0.32, but if you use the answer key, it's more accurate. And then f would be about 18.78 degrees, so I'm going to round that to 19 degrees. So if that's 19 degrees, we can figure out angle E. So the next angle, so angle E, we're going to take 180 minus 105 minus 19. And when you do that, you can get angle E. And let's see if this has popped up yet. Not yet. Okay. So if you calculate that angle, I think it's about 10. Let me double check. 180 minus 105 minus 19. 56. Okay, so it's 56 degrees. Okay, and then lastly, we can solve for side E, which is over here. And so again, you have to set up your proportions. So I'm going to do it over here since I'm out of room. Again, choose one of your ratios. I'll use sine of 105 over 12 just because it's more accurate. Equals sine of 56 over side E. Cross multiply and solve. So we get E sine of 105 equals 12 sine 56. Divide each side by sine 105. And I get side E is about 10.3. So we can use law of sines to solve for the complete triangle. Last example, now this has finally popped up. We don't need it anymore. All right, last example, towers A, B, and C are located in a forest. Tower B, from Tower B, the angle between towers A and C is 53.3 degrees. There it is. And from Tower C and A, it's 46.7. The distance between towers A and B is, okay, 4,084. A lake between the two towers. Okay, what is the distance between A and C? So this is what we want, side B. law of sines, because if you do 180 minus these two, you can get this angle, and that's not 90. So law of sines. Sine of 53.3 over b equals sine of 4084 over, oh, I'm sorry, I put the side, it needs to be the angle, sine of 46.7 over 4084. All right, we'll cross multiply. We'll get b sine 46.7 equals, go the other way, 4084 sine of 53.3. And then last step, divide each side by sine of 46.7. And you will get your answer. B is about 5,292.5 meters across. So your assignment will be to practice using law of sines, and in the next lesson we'll look at law of cosines.